Hi guys! The video that you're watching today is on Standard 7, one-step equations. By the end of the video, we hope that you'll be able to solve one-step equations by using the addition property of equality and the subtraction property of equality. When you're solving one-step equations, like the equation you see here, your goal is always going to be to isolate the variable. In order to isolate the variable, we're going to treat this equation just as we would the scale over here. Just as the scale has two sides to it, our equation also has two sides to it, x plus 2 and 4. And you'll notice on my scale, if I add a weight to the left-hand side, in order to balance it out, I also have to add a weight to the right-hand side. And so that brings us to the golden rule of math. The golden rule of math is what I do to one side, I must do to the other. When we look at the addition property of equality, we're going to really be able to see how the golden rule of math comes into play. The addition property of equality states that if I have an equal equation, just as I do this 9 equals 9 here, if I add something to the left side, I have to add that same thing to the right side in order for my equation to stay equal. Let's see. So if my equation is 9 equals 9, and I add 2 to the left-hand side of my equation, I'll have 11. In order for my final statement to still be true, I have to add 2 to the right-hand side as well, so that my final statement says 11 equals 11. Let's see how this works when we work with variables. Example 1 is x minus 72 equals 11. First things first, I'm going to draw my bar, which reminds me that what I do to one side, I must do to the other. So if our final goal is to isolate the variable, or, in other words, to get the x all by itself, I'm going to have to undo the subtraction that is happening right here. And how do I undo subtraction? Well, I'm going to add 72 to the left side. But like our golden rule states, what I do to one side, I must do to the other. So if I add 72 to the left, I'm going to have to add 72 to the right. When I do that, I'll still have x on the left-hand side. My minus 72 and positive 72 are going to cancel out to be 0. So we don't really have to write that here. I'm going to bring down my equal sign, and then I'm going to add 72 and 11 to get 83. So far, it looks like my x equals 83. But what I need to do is I need to check my answers. Each time you work an equation and you solve for a variable, what you're going to do is you're going to take the number that you get and you're going to plug it back into your original equation. Let's see. If I found that x equals 73, if I plug it back into this equation, I should see that it's true. My original equation was x minus 72 equals 11. I'm going to plug 83 in for x and get 83 minus 72. When we reduce that, we get 11 equals 11, which is a true statement. Therefore, our final answer is x equals 83. Let's do another one. In this example, I have negative 8 plus x equals 16. Once again, if I'm solving for x, I'm going to draw my bar so I know what I do to one side, I must do to the other. In order to get x all by itself, I have to undo this negative 8. In order to do that, I'm going to add 8 to both sides. When I do that, negative 8 plus 8 cancels out to equal 0, and I'm just left with x on the left-hand side. And then 16 plus 8 is 24. But I still have to check my answers. We're going to rewrite our original equation, negative 8 plus x equals 16. I'm going to plug 24 in for x. Negative 8 plus 24 equals 16. I'm going to reduce this down, and I'll have 16 equals 16. So it looks like it checks out. My final answer is x equals 24. So you might be wondering, well, what happens if I want to subtract something from both sides? Am I going to have to do the same thing? Well, that's what the subtraction property of equality states. It states if I have an equation that is equal, just like this 9 equals 9 here, if I were to subtract something from the left-hand side, I'm also going to have to subtract it from the right-hand side. 9 minus 2 is 7. In order to make the right-hand side 7 as well, I need to subtract 2 from the right-hand side. I'll be left with 7, or 7 equals 7, which is a true statement. So let's practice the subtraction property of equality. Example 3 says 18 plus x equals 40. First things first, I'm going to draw my line to make sure what I do to one side, I must do to the other. If my goal is to isolate my variable, I'm going to subtract 18 from the left so I can undo this adding 18. I'm going to subtract it from the right. These 18s are going to cancel out to be 0. I'll just be left with x. And we have 40 minus 18, which is 22. Let's check. My original equation was 18 plus x equals 40. I'm going to plug 22 back in for x, and I'll have 18 plus 22 equals 40, which reduces down to 40 equals 40, and that is a true statement. It checks out. All right, let's try one more example. So my new equation says p plus 13 equals 25. I'm going to draw my line, and then I'm going to subtract 13 from the left, subtract 13 from the right. I'll be left with p, my 13 minus 13 cancels out to be 0, equals 12. And now we're going to check. My original equation said p plus 13 equals 25. I'll plug 12 back in for p. 12 plus 13 equals 25. 12 plus 13 is indeed 25. Therefore, I have a true statement. Now, you try to. Go ahead and pause the video now. This first problem is using the subtraction property of equality. And we know this because we see we need to subtract off 5 in order to get the variable g all by itself. I'll subtract 5 from the left and then from the right. I'll be left with just a g on the left-hand side because my 5's cancel out. 5 and minus 5 is 0. And then I'll do 33 minus 5 on the right and get 28. If we go back in and check, we see that 28 plus 5 does indeed equal 33. Therefore, we know our final answer is g is 28. On number 2, we are going to be using the addition property of equality. In order to get the variable all by itself, I'm going to first add 4 to the left side, and then because I'm following the golden rule of math, I'm also going to add 4 onto the right. My 4's will cancel out here, leaving me with just t. And then my right-hand side, I'll have negative 3. But I need to check my answer. So I'm going to plug 3 back in, or negative 3 back in for t. I'll have negative 4 plus negative 3 equal negative 7. Negative 4 plus negative 3 is negative 7. Therefore, I have a true statement. If you have any questions, be sure to ask your teachers tomorrow. Good luck!